Okay, excuse me. Okay, one of these two gives you an answer. One of those two is impossible. It's impossible to do. And students mess these up a lot. So what I want you to do is know how to fix that yourself. So on your blue calculator, well, first ask yourself real quick in your head, what do you think the answer to this is? What do you think the answer to that is? It's not the same answer, by the way, okay? Once you've answered it in your head, go try it on your calculator. Go do 3 divided by 0 and do 0 divided by 3. I'm going to show you. But try them both. That way you can see for yourself, because you'll forget which one you can do, which one you can't do, or you'll mix them up. So I'm showing you how to test it with the calculator. E stands for error. Okay, did you guys see? You can do this one. The answer is just 0. Okay, you can't do this one. Okay, I think on yours it gives the E, doesn't it? The letter E. Yeah. Okay, so we can never in math. You can never divide by 0. There's this cool video out on the internet on the calculators. Before they had digital calculators, they had mechanical calculators, and they try to divide by 0 and it like breaks it. It just starts clicking on forever. If I have time and you remind me, I'll show you. But you can't divide by 0, okay? And now that's the reason I'm showing you this for domain. So let me see, where's that at? Domain. So let's go to an example so you can see example 1. And let's have f of x equal 3x plus 2. Okay. So I just proved to you that we can divide by 0. Okay. So if I take the denominator, the bottom, it can't be 0. I can say, well, I know that whatever that bottom is, whatever it is, it can't equal 0. Because if it does, I get an error. Right? It breaks the calculator. So what number is that it can be? So I solve this little equation, and it tells me that x cannot equal -2. Yeah, and now you can test it super fast, because what is -2 plus 2? 0. So that would cost 0 on the bottom. Does that make sense, guys? Okay, so for domain, okay, for rational functions, the domain will be all real numbers. That's what that R stands for, all real numbers, except for discontinuities. And you're like, what are discontinuities? That's the bottom part that we did, the bottom that can't equal 0. Okay, so more specifically is this, I can't tell you the names because we haven't done the notes for it, but that's going to be your whole. It can't be a whole, that's called a discontinuity. Okay, and it can't be a vertical asymptote. Those two are called discontinuities. Okay, and it can't be those because those cost zeros at the bottom. Okay, so let me show you. So the domain, for example, for this example that we did, okay, I would say my domain is from -infinity, because all real numbers comes from -infinity, except it can't be -2. So I get to -2 and I have to jump over that -2. So all real numbers except x can't be -2. Okay. Let me show you another quick example just so I can bring it home for you. So let's do example 2 here. Okay. Let's say you guys had f of x equal x plus 1. And then here we had x plus 5, x plus 3, and x minus 2. Now, let me ask you a question, guys. When I have a parentheses and another parentheses next to it, what are the parentheses trying to do to each other? Multiply, okay? So If one of these parentheses is 0, what's 0 times anything? 0. So none of these three could be 0, because if any of these three are 0, they're going to make the others turn into zeros. Okay, so for my discontinuities, I know that x plus 5 cannot equal 0. I know x plus 3 cannot equal 0. And I know that x minus 2 cannot equal 0. Because any of those three that equals 0 will cause me the whole bottom to be 0. And therefore, you get that error. Okay, so if I solve these, subtract 5, subtract 3, add 2, add 2. So x cannot equal negative 5. X cannot equal negative 3. X cannot equal negative 2. Oh, positive 2. Sorry. Go ahead, Kingston. Yeah, it's related. So here it is. Look at the domain, how I see this. Domain from negative infinity. Now, if I'm walking on the x-axis from negative infinity and I'm walking along, who of these three is going to show up first? Negative 5. So they do go in order. Jump over negative 5, and then I keep on walking after negative 5. Who comes next? Now, they just happen to be in that order, but they could be in other order. Okay, so jump over negative 3. Which one? The 2 is positive at the bottom. Yeah, I had wrote it negative initially, so that's probably why you had it negative. And then I fixed it after that. U is the union where you're jumping over that spot. Or in other words, this goes out, it's like the glue that's holding all this. It's one single domain, but we're jumping over that spot.
Will it be negative infinity to start it off?
Yeah, it will always be negative infinity, and you will end with positive infinity because it's all real numbers except for those spots. Okay, notice these spots where they come from, right? So here's this discontinuity, here's this one, and there's that one. That's what x can't be. So you have to jump over those. And you're about to find out why we have to jump over them. You're about to find that out. Are we good so far though? Questions, guys? Any questions? Okay, so this leads us to part 3.